Hello everyone, welcome to our YouTube channel. In this video, we are going to solve the question on center of mass. So let's look at the question. We have two semicircular rings of linear mass densities lambda and 2 lambda of radius r each. Okay, so basically we have two semicircular rings which are joined like this. Okay, to form a complete ring. Both are having same radius. So this is r radius. Okay, now what is happening, the distance of the center of mass of the complete ring from the center is how much? So let's say this is the origin. Okay, now this one will be at a height 2r by pi. Okay, this one is having a mass lambda times r. This one is having mass 2 lambda times r. Sorry, not lambda times r, lambda times pi r, and this is having 2 lambda times pi r. This is the mass of the lower ring, this is the mass of the upper ring. Okay, correct. So now where will be the center of mass for this? This is 2r by pi, and this one will be again 2r by pi, correct, with a minus sign because it is downwards. So now YCOM will be lambda times pi r, this is the mass, times 2r by pi plus 2 lambda times pi r into minus 2r by pi divided by the total mass, that is 3 lambda pi r. This is the total mass. So we can see from here that we have lambda times r as common. This pi and pi will get cancelled. Lambda times r is common, so we can cancel out that also. So here we get YCOM to be 2r minus 4r upon 3 pi. So this is minus 2r by 3 pi. So the magnitude basically is 2r by 3 pi. So the correct option is this one, that is the second option. Okay, thanks for watching this video, and please subscribe to our YouTube channel to get more video solutions like this.